Okay, so today's topic, as I informed earlier, is called spin caloritronics. Spin caloritronics. Okay. So it is basically a conjunction of charge, conjunction of heat, and spin. So from charge, there is associated charge current, the normal current that we have. This is heat flow, and this is spin flow. So these are all current densities. Something which is flowing per unit area. Either it is a charge, either it is the heat, or it is the spin. Now, spin caloritronics, it says that these three have a interconversion between them. स्पिन से हीट जनरेट होता है, हीट से स्पिन जनरेट होता है. There is a Seebeck effect. When you are aware, Seebeck effect is the interconversion between heat in formation of current. Right? From heat to current is Seebeck effect. Peltier effect. Seebeck. Seebeck पता है ना? Seebeck, Peltier. What is Peltier? From charge generation of heat. Okay. And the constant which governs this Seebeck effect is called Seebeck constant. It is called Peltier constant. Peltier. SOP are the constants. Seebeck, S is the Seebeck constant, P is the. That means if there is a change in JC, it is proportional to S. Right. And JU change in charge, if it produces heat, then it is called Peltier effect, and it is governed by this Peltier constant. Change in temperature, if it is causing a current, then it is a Seebeck constant. Right. Similarly, instead of Seebeck, instead of the normal charge current, there is something called a spin current. This is called spin current. This will be spintronics based. electronics. Spin of electron. Plus spin up, spin down, spin of electron. So there is a term called mu. Thermodynamics में जितने भी potentials है, उनमें से एक potential है mu, and it is actually called the chemical potential. Now, chemical potential is associated with a number of something. So, if we have, say, if I say mu s, what I mean is the number of states available. Right. Now, as this Seebeck coefficient relates normal current with temperature. Similarly, if we consider the spin current, right? If we consider the spin current, then the spin current Js, I can write it as equal to S suffix S minus del T. So, similarly, gradient in temperature is causing a spin current. और इस कंडीशन में ये जो टर्म है, ये कांस्टेंट है, this will be called spin Seebeck coefficient. जस्ट मैंने C को S से रिप्लेस किया, राइट? What is actually a spin current? How do we define a spin current? That is the question. I'm coming to that. How do we define a spin? So अभी तुम लोग देखो कि ये the similarly you can also relate JQ with spin current as a change in potential. Change in potential is causing heat, right? So that makes this constant as ये वाला कांस्टेंट हो जाता है स्पिन पेल्टियर कोएफिशिएंट. तो ये जो सारे रिलेशनशिप्स हैं, all these relationships, inter-converting relationships between these three entities, they can be expressed by a transformation matrix. They can be expressed in terms of a linear transformation where I am expressing J as equal to Lij. So this is I and J. इसमें कुछ प्रॉब्लम नहीं है, it's very much clear. So this is the column matrix. So this is 3x3 matrix, and again its shape is the column matrix, and this is the linear transformation. Now, what should be the terms? जो लेफ्ट हैंड साइड में वो तो वेरी मच क्लियर है. There will be the different currents, be JC, JS, and JQ, right? Or the cause can be electric field, right? Change in number of spins, gradient in the spin chemical potential change, or it can be a temperature. Temperature minus है because temperature flows from higher to lower, इसलिए minus है. अच्छा, फिर ये जो यहाँ पे 9 कंपोनेंट्स होंगे, ठीक है. पहले हम लोग कंसिडर करते हैं डायगोनल कंपोनेंट्स. डायगोनल कंपोनेंट्स को अगर देखा जाए तो I am taking I as equal to C I is equal to what? C, S and Q. तो मैं अगर यहाँ पे I can take I can take different values C, S and Q. So I can write here CC, SS, ठीक है. So it's clear up to this point. CC,
जब यहाँ से लैब
हाँ ठीक है. CC, LS, LSS and CC. ओके. तो इसका करेस्पॉन्डिंग इक्वेशन क्या होगा? इलेक्ट्रिक फील्ड इज कॉजिंग अ current density. So if electric field is causing a current density, you can take this one as the conductivity of the material, the normal electrical conductivity sigma. Okay. This can be the conductivity of the spins, right? And this can be thermal conductivity. यहाँ पे कोई दूसरा कंपोनेंट नहीं है, सिर्फ चार्ज की जगह पे चार्ज है, स्पिन की जगह पे स्पिन है और हीट की जगह पे हीट. Complication arises with this the next 6 stages. ये जो 6 कंपोनेंट्स यहाँ पे है, they are very complicated. So if this is LC, what should be this one? क्या होगा? L C LCS ये वाला क्या होगा? L S C L S Q ये वाला क्या होगा? L Q C इसका मतलब है कि my JC is related to, I can write JC as equal to L JC as equal to LCS into some component of S plus LCQ some component of Q For the first case, similarly I can write Js as equal to LSC, and lastly I can write C. Okay. These are called on-site ratio. On-site ratio. Mathematically, you have understood. Now, physically, इसका मतलब क्या है? जो हम लोग लिख तो रहे हैं, लेकिन how is it happening? What is causing this heat to get converted into spin? तो इसके लिए एक तो I have already explained to you the effects. One of them is called spin Seebeck. SSE. Spin Seebeck effect में क्या हुआ है? There is some gradient in temperature. समझ लो gradient in temperature. Gradient in temperature is causing a spin current. What is a spin current? Spin current is when the electron is without any charge but only based upon its spin. इसका example है, there is something called magnetic insulators. Magnetic insulators, and very good example of this is YIG. It's called yttrium garnet. Yttrium iron garnet. So ये formula है Y5 तो यहाँ पे लिथियम है in oxidation state +3, right? This is in oxidation state -2. Every oxidation state कितना होना चाहिए यहाँ पे? What should be the oxidation state of Fe? No, sorry. ये है पहले वाले तो इसका -24 and 9. So yttrium का oxidation state is +3, so that is +5. So it is +6 oxidation state. Now this existence of this Fe plus oxidation state structurally It consists of two subatomic units. Due to having these two subatomic layers, इससे क्या होता है कि the property of फेरीमैग्नेटिज्म मतलब the spins are aligned but one of them is shorter. Spins are aligned. ठीक है, लेकिन यहाँ पर the next spin है one of them is short. Ferrimagnetism. Right. So this leads to some inherent magnetization existing in these materials. Normal ferromagnetic में क्या होता है? Exchange interaction होता है. These two Si and Sg interact. तो यहाँ पे क्या हो रहा है? There is some residual magnetization, that is N. अच्छा, now it is coming back to this magnetic insulators. Magnetic insulators में खासियत है कि यहाँ पे only the spins are having momentum, spin angular momentum, but there is no electronic charge movement. इसलिए इसको insulator कहा जाता है. Magnetic कहा जाता है because it has not spin, and insulator इसलिए कहा जाता है because there is no flow of electron. ठीक है, तो इसीलिए in YIG okay, this represents a ferrimagnet. इस कंडीशन में if there is a gradient of temperature, right, वो क्या करता है कि ये जो छोटा वाला the one which has got a weak magnetization causes a flip, spin flip, ठीक है, due to the heat. और spin flip करने से the one thing that gets generated is spin waves. There are some spin waves. अचानक से flip करोगे तो उसका reaction होगा. There are some spin waves generated, and these spin waves are quantized. और उनका क्वांटाइजेशन को हम लोग बोलते हैं मैग्नॉन्स. Magnet is a quasi-particle. Quasi-particle means it is not a real particle, but it is, you can call it as an effective particle. जैसे effective mass होता है, इसी तरह से due to the surroundings, if you consider any mass which is not really existing, but to simplify the things, बहुत सारे इंटरेक्शंस को अगर हम एक ही सिंगल पार्टिकल के मोशन से एक्सप्लेन करना चाहें तो वी यूज मैग्नॉन्स, सॉरी वी यूज क्वासी पार्टिकल्स, एंड वन ऑफ देम इज मैग्नॉन. देयर हैव बीन अदर क्वासी पार्टिकल जो तुम लोगों ने पढ़ा है, जैसे कि कोलोरॉन्स पढ़ा है, और पढ़ा है इंजीनियरिंग में पढ़ा है कोलोरॉन्स. वेयर डू दे एग्जिस्ट? इन कंडक्टिंग पॉलीमर्स. ठीक है, there is something called Cooper thread. You know what is Cooper thread? Cooper thread, plasmon, phonons. lattice vibrations. All these are possible particles. So similar to that, we have a magnon, which is the quantized spin wave. ठीक है, तो इसके फ्लो को हम लोग बोलते हैं फ्लो ऑफ स्पिन करंट, क्योंकि जितना ज़्यादा मेरा डेल्टा मोर आई विल हैव अ ग्रेडियंट ऑफ स्पिन्स. ग्रेडियंट ऑफ स्पिन्स मतलब डिफरेंसेस इन अप स्पिन एंड डाउन स्पिन जितना ज़्यादा होगा उतना ज़्यादा मेरा मैग्नॉन क्रिएटेड होगा. सो एंड there is something called the magnon current also. This represents the magnon current. और जो spin is represented by the spin current is the magnon. So this represents the number of magnons, or this is the number of spins. Okay, they are related to each other. ठीक है. So we have understood what is the spin Seebeck effect is. उसी तरह से spin Peltier effect भी होता है. अच्छा, उसको मैं हम लोग बात में आते हैं. Next thing that like to know Hall effect. जानते हैं इसको बोलते हैं Hall effect. HE. What is a Hall effect? If we apply electric and magnetic field in perpendicular direction, there is a voltage generated which is perpendicular to both electric and magnetic field. ठीक है ना? This is the Hall voltage. So we also have something called a spin Hall. Spin Hall. Spin Hall. What is the spin Hall effect? It is again the generation of current due to तो मैंने शेयर किया है ऑलरेडी एग्जैक्ट स्पिन ऑन इफेक्ट का तो शेयर किया था. तो यहाँ